And when we did, the block mode application ran any place from 2 to 5 times as fast as the character mode application.
5 times?
5 times as fast. And to explain why, we've prepared just a little vignette that I think will illustrate the reason why. Let's look at it now.
All right, to explain the difference between character mode and block mode, we're going to let this terminal here represent a terminal. We're going to let these blocks right here represent a real simple transaction. And we're going to let this path behind me represent all the work that the system has to go through to process the transaction. Now my assistant here is going to take care of all the data communications and all the operating system overhead that you have to go through to get these letters transmitted down to the host. Are you all ready to start? Okay, then I want you to take this first character and I want you to deliver it to my other assistant who's in that building down there at the far end of the yard. Are you ready? On your mark, get set, and go. Now, the first thing the system has to do is to transmit the data over the wire between the terminal and the host computer. Now, using today's telecommunications technology, the character will arrive at the host almost instantaneously. But this is where the hard work really begins. When the character arrives, the host has to figure out which process this character belongs to. Now, on a small system, like a workstation, this isn't a big deal. There's only a few processes to choose from. But on a large computer, like a mainframe class system, there could be hundreds or even thousands of active processes to choose from. And it's going to take system resources to find the right one. This is called scheduling the process. Now the operating system has to get the process ready to accept the character. We have to locate the stack, possibly some buffer space or the heap. Now the application has to contain logic to examine the character in order to ensure that this is a piece of data and not just a command. When satisfied that this is just data, the application will post a read on the terminal to get the next character. Now, if that seemed like an awful lot of work, well, it was. But there's a more important point. Not only do we have to dispatch the application, schedule it, aside from transmitting the data down the wire, and potentially swap in things like the stack and the heap for every single character that we type, we have to do that over and over and over again. Every character, we go through all the overhead again. And it gets worse than that, actually. Don't forget that if the user makes a typing error, we have to fix that down on the host as well. Excuse me. That was supposed to be an O that I sent down to the other table, and I think I may have accidentally sent a 0 down instead. Now, to fix that, I'm going to give you this backspace character. What I want you to do is to take that down to the other end, get the O, and bring it back. And hurry up, go as quickly as you can. Now, if that seems like an awful lot of work, it is. I don't know about you, I like working smart a whole lot better than I like working hard. And that's really what block mode is all about. It's about working smart when you're doing terminal I/O instead of working hard. And to show you how block mode works, I'm going to switch assistants here. Now, in block mode, what we do is instead of transmitting the characters down to the host one at a time, we transmit the whole screen's worth of data together in a single block. But what's more important is that if we happen to make a typing error or if we need to change something, we can do that here at the terminal end of the wire. Like I notice we've got 2 of these here interchanged. And when the transaction is all ready to go, you can take it down to the host computer at the other end of the path. We still have to go through the system overhead. We still have to dispatch the application, schedule it, potentially swap information in from disk. But the important thing is we only have to do it once per transaction instead of once per character. So the system overhead goes way, way down, and we can be much more effective in the way that we do OLTP in a block mode environment.
Okay, George. So what you're saying is that in character mode, the system has to go through the overhead of scheduling and dispatching the application program every time the user types a character.
Right. And that's really the beauty of block mode. It's not that the terminal I/O is faster. That really, you're right, that really doesn't amount to much. But what is important is that instead of having to redispatch and reschedule the application over and over and over and over again to do a transaction once per character, we can do it once per screen, which means